Hello friends, I welcome you on my channel Engineering Mathematics is a Ganit. From last 3 lectures we are discussing indeterminate forms and how to find out limits of this type of forms using L'Hospital rule. Today we are going to discuss indeterminate forms of these 3 types: 0 to the power 0, infinity to the power 0 and 1 to the power infinity. All these 3 quantities are undefined form or meaningless form, so we can say that they are indeterminate forms. So whenever we have limits of this form, if we have this type of limits, then this type of indeterminate forms may arise. So depending upon the limits of fx and gx as x approaches a, we will have this type of indeterminate forms. Suppose limit of fx is 0 and limit of gx is 0, then this limit will be indeterminate form of type 0 to the power 0. If limit of fx is infinite and limit of gx is 0, then this limit will be indeterminate form of type infinity to the power 0. And if limit of fx is 1 and limit of gx is either infinity or minus infinity, then we have indeterminate form of the type 1 to the power infinity. So for each of these 3 indeterminate forms, the method is common. We will first assume that this fx to the power gx is some another function of x denoted by y. So to evaluate this type of indeterminate forms, we will start by taking fx to the power gx equal to y, and then we will take logarithm on both the sides. After taking logarithm, we will apply or we will take limits on both sides. So if I take limits on both sides as x approaches a, I have limit of log y as x approaches a equal to limit of gx into log fx as x approaches a. So this right hand side will be an indeterminate form of the types which we have discussed in previous lectures. So we can evaluate this limit using methods of previous 3 lectures, and after evaluating this limit we can find out this one. So this we understand with the help of examples. Calculate limit of 1 plus sin 4x to the power cot x as x approaches 0 from right hand side. That is, this is one sided limit. So first we decide here fx is 1 plus sin 4x, gx is cot x. So if we take x tending to 0 from its right hand side, 1 plus sin 4x becomes 1 plus sin 0, that is 1. That means x as x approaches 0 from right hand side, 1 plus sin 4x approaches 1. Similarly, as x approaches 0 from right hand side, cot x is cot 0, which is cos 0 over sin 0, and cos 0 is 1, sin 0 is 0, so that is infinity. That means as x approaches 0 from right hand side, cot x approaches infinity. So we can say that this is an indeterminate form of the type 1 to the power infinity. So we have to consider this function equal to y, and then we will start by taking logarithm. So we start by taking y equal to 1 plus sin 4x to the power cot x, and then we take natural logarithm on both sides. So log y equal to log of 1 plus sin 4x to the power cot x, and using property of logarithm we can write log of 1 plus sin 4x to the power cot x equal to cot x into log of sin 4x plus 1. Then we take limit as x approaches 0 from right hand side. So we apply limits on both sides. Limit of log y as x approaches 0 plus equal to limit of this product as x approaches 0 plus. Now again, if we take x equal to 0, here we will have cos 0 over sin 0, that is 1 by 0, which is infinity. And if we put x equal to 0 here, we will have 1 plus sin 0, and sin 0 is 0, therefore this is log 1, and log 1 is 0. Therefore this is an indeterminate form of the type infinity into 0. So as we have discussed in previous lectures, we cannot apply L'Hospital rule for this type of indeterminate form. Therefore we have to either convert it into 0 by 0 or infinity by infinity. So we can rewrite this product as log of 1 plus sin 4x divided by 1 upon cot x, which is tan x. So we rewrite this product as log of 1 plus sin 4x divided by 1 over cot x, which is tan x. Now if we take x approaching 0, then we have log 1, which is 0, and tan 0 is 0. Therefore this is indeterminate form of type 0 by 0. So we can apply L'Hospital rule. So if we apply L'Hospital rule, we have to take derivatives of numerator and denominator separately. First we have written derivative of log of 1 plus sin 4x, which is 1 over 1 plus sin 4x into derivative of 1 plus sin 4x, which is 0 plus cos 4x into 4. And in the denominator we have to write derivative of tan x, which is sec square x. Now we take x equal to 0. So if we take x equal to 0, we have 4 cos 0, which is 4. Here we have 1 plus sin 0, that is 1, and sec 0 is also 1. So we arrive at 4. This limit is 4. Now left hand side is limit of log y as x approaches 0. So therefore we obtain this. Now because log y is continuous function, we can interchange this limit and log. So log of limit of log y equal to log of limit of y as x approaches 0 from right hand side, and which we have obtained as 4. So because log x is continuous function, we can interchange limit and log. Now we use this property, or we know that logarithmic function and exponential function are inverse of each other. So if we have log alpha equal to beta, then we have alpha equal to e to the power beta, and converse is also true, because exponential and logarithmic function are inverses of each other. So here you can see we have log of limit of y equal to 4. So instead of alpha we have limit of y, beta is 4. So therefore limit of y as x approaches 0 plus is nothing but e to the power 4. And finally we put value of y, which is 1 plus sin 4x to the power cot x. So this limit has value e to the power 4. So whenever we have this type of indeterminate powers, we will consider this pattern. We will first assume given function equal to y, and then we will take logarithm on both sides, and we will try to see whether we can apply L'Hospital rule or not. Next example, limit of x to the power x as x approaches 0. So if we take x equal to 0, we have 0 to the power 0, which is indeterminate form. So we start by taking given function is suppose denoted by small y. Therefore log y equal to log of x to the power x, which is x into log x. Now we apply limits on both sides. Therefore limit of log y as x approaches 0 plus equal to limit of x into log x as x approaches 0 plus. And if we take x equal to 0, we have 0 here, and log 0 is minus infinity. Log 0 is negative infinity. So we have again 0 into infinity form. So this x is written as 1 over x. So if we write x into log x as log x over 1 over x, and if we take x equal to 0, then we have log 0 which is minus infinity, and here 1 over 0 which is infinity. So this is infinity by infinity form. So for this limit we can apply L'Hospital rule. So if we apply L'Hospital rule, we have to write derivative of log x in the numerator, which is 1 by x, and derivative of 1 by x in the denominator, which is minus 1 by x square. And if we simplify this is nothing but 1 by x and minus x square by 1. So x will cancel out. We are left with 1x and negative sign, and limit of x as x approaches 0 is 0. And right hand side is limit of log y as x approaches 0. So therefore limit of log y as x approaches 0 is 0. Because log is continuous function, we have interchanged log and limit. So log of this quantity or log of this limit is 0. Therefore this limit equal to e to the power 0, which is 1. Here we are using the property that if ln alpha is beta, this implies alpha equal to e raised to beta. So using that property, we have written this step. Log of limit y equal to 0, therefore limit of y is e to the power 0, and e to the power is 0 is 1, and we put y equal to x to the power x. So in this way we can easily evaluate this type of indeterminate powers also with the help of this logarithmic function and L'Hospital rule. We consider one more example. Limit of 1 by x to the power 10x as x approaches 0 from right hand side. So we start by taking y equal to 1 over x to the power 10x. Then we take logarithm on both sides. Therefore log y is log of 1 by x to the power 10x, which is 10x times log 1 by x, using property of logarithm. Then we take limits of both sides. So therefore limit of log y as x approaches 0 equal to limit of 10x times log of 1 by x. Now if we take x equal to 0 here, we have tan 0, which is sine 0 over cos 0, and because sine 0 is 0 and cos 0 is 1, this is tan x is going to be 0 as x approaches 0. And if we take x equal to 0 here, we have log infinity, because if we take x equal to 0, we have log of 1 by 0, which is going to be infinity, and log infinity is also infinity. So this indeterminate form is 0 into infinity form. So we try to write it as infinity by infinity or 0 by 0 form. So we can rewrite this 10x as 1 over 10x, that is cot x. So therefore 10x into log 1 by x is rewritten as log of 1 by x over cot x. Now this is infinity by infinity form. You can check, this is for x equal to 0 we have log infinity, which is infinity. For x equal to 0, cot 0 is cos 0 upon sin 0, and cos 0 is 1 and sin 0 is 0, so 1 by 0 is infinity. Therefore we again we apply L'Hospital rule. So derivative of log of 1 by x is 1 over 1 by x into derivative of 1 by x, which is minus 1 over x square. In the denominator, derivative of cot x is written as minus cos x square x. Now here we can check negative sign will cancel out, and we have this 1 over 1 by x is nothing but x, so that 1x will cancel out with this x, so we are left with 1 by x, and this we rewrite as 1 over sin square x. And if we rewrite this again, this is nothing but 1 by x into sin square x, which is sin square x by x. This is again 0 by 0 form, so we apply L'Hospital rule. Again derivative of sin square is 2 sin x into cos x, and derivative of x is 1. So this 2 sin x into cos x can be written as sin 2x, and if we take x equal to 0, limit is 0, and right hand side is limit of log y as x approaches 0, so this limit is 0. And if we use the property of logarithmic function, because log x is continuous, we can interchange this limit and logarithm. So limit of logarithm of y equal to logarithm of limit of y, and again using the property of logarithmic function, if log of limit of y equal to 0, then limit of y equal to e to the power 0, which is 1, and finally we put y equal to 1 by x to the power 10x. So in this way it is easy to find out this type of indeterminate powers. We just have to use logarithmic function and L'Hospital rule. Some more examples we can also discuss. Suppose we consider this one. Here we have limit of a to the power x plus b to the power x plus c to the power x over 3 and whole bracket to the power 1 over 3x. So for x equal to 0, we can see this is a raised to 0 plus b raised to 0 plus c raised to 0. So all are 1. Therefore we will have 1 plus 1 plus 1 over 3, that is 1, and to the power 1 over 0, which is infinity. So this is 1 to the power infinity form. So we start by assuming this function equal to say y, then log y is nothing but log of this bracket to the power 1 over 3x, and 1 over 3x can be taken in the product using property of logarithmic function. So this we can rewrite as 1 over 3x log of this bracket. Now if we apply limits on both sides, limit of log y as x approaches 0 equal to limit of 1 over 3x times log of this bracket. Now here we can take 1 over 3 outside, and if we check for this, 1 by x is 1 over 0 as x approaches 0, so 1 by 0, which is infinity, and if we take x equal to 0, here we will have log 1, that is 0. So this form is not 0 by 0, it is infinity by infinity form. So we rewrite this limit as log of this bracket divided by x, and if we now check, it is 0 by 0 form. Therefore we can apply L'Hospital rule. So this is equal to 1 over 3 limit of x, limit x approaches 0 from right hand side, derivative of this log of this bracket equal to 1 divided by this bracket into derivative of this bracket divided by derivative of x, which is 1. this 1 over this bracket can be rewritten as 3 over a raised to x plus b raised to x plus c raised to x. Here 3 is constant, so that remains as it is. Derivative of a raised to x is a raised to x log a. Similarly, derivative of b raised to x is b raised to x log b, and derivative of c raised to x is c raised to x log c. Now here we can cancel out these 3 and this we rewrite in this form. Now if we take x equal to 0, then we have a raised to 0 which is 1. So log a plus b raised to 0 which is 1 log b plus log c, and here a raised to 0, b raised to 0, c raised to 0, that is 1 plus 1 plus 1, and this we can rewrite as log of a into b into c using the property of logarithm, and this is going to be 3 into 3, so we have 1 by 9 into log of abc. And using property of logarithmic function, this we can rewrite as log of abc to the power 1 by 9. Therefore, we obtain limit of log y equal to log of abc to the power 1 by 9. And because again log is continuous function, so we can interchange logarithmic function with this limit, and this is log of abc raised to 1 by 9. So therefore limit of y as x approaches 0 equal to abc to the power 1 by 9, and finally we have to put value of y which is a raised to x plus b raised to x plus c raised to x by 3 to the power 1 by 3x is abc raised to power 1 by 9. So these are the examples related to indeterminate powers. And last example, limit of tan x over x to the power 1 by x square as x approaches 0. So here if we consider fx equal to tan x by x, then limit of tan x by x as x approaches 0 is always 1. So we have 1 here, and this is going to be 1 over 0 which is infinity. So this is indeterminate form of the type 1 raised to infinity. So we start by taking given function tan x by x to the power 1 by x square equal to say y. Therefore log y is log of tan x by x to the power 1 by x square equal to 1 by x square log of tan x by x. Now we take limits on both sides. Limit of log y as x approaches 0 equal to limit of this product, and if we take x equal to 0, we have 1 by 0 that is infinity, and log of limit of tan x by x which is going to be log of 1 which is 0. So we rewrite this as log of tan x by x over x square. So we can check this is 0 by 0 form, because here if we take limit tan x limit as x approaches 0, then we have log of tan x by log of limit of tan x by x, and limit of tan x by x is 1, therefore log 1 is 0. So we have to apply L'Hospital rule. So first we consider derivative of this. So derivative is 1 over tan x by x, so that we have written as x over tan x, into product we have to write derivative of tan x by x. So x as it is, derivative of tan x is sec square x, minus tan x as it is, derivative of x is 1, divided by square of x which is written here. Now here also we have standard limit, so we can break this limit, and we have taken 1/2 outside, it is constant. So this limit is rewritten in this form as a product of two limits, limit of x over tan x into limit of x sec square x minus 10x over x cube. Now this limit is going to be 1, so we have 1 by 2 limit of x sec square x minus 10x over x cube. And if we take x equal to 0, again we have 0 minus 0, that is 0, and this is also 0 for x equal to 0. So we have 0 by 0 form, and this we have written as 1. So we again apply L'Hospital rule. This is as it is, 1 by 2 as it is, x as it is, derivative of sec square x is 2 sec x into 10x. So that we have written here, derivative of sec square x is 2 sec x into derivative of sec x. So we have written 2 sec square x into 10x. So x as it is, derivative of sec square x is 2 sec x into sec into 10 plus sec square x as it is, derivative of x is 1 minus derivative of 10x is sec square x. In the denominator we have 3x square. So you can see here sec square x will cancel out, and this 2 will also cancel out, but we write one more step. We can write this 2 into 3 as 1 by 6, and we keep this 2 as it is. So we have limit of 2x sec square x 10x over x square, and this 2 we have taken outside in the next step, and we have limit of sec square x into 10x divided by x, because we have x square here, so 1 x will cancel out, and this we again rewrite as product of two functions, limit of 10x by x into limit of sec square x, and sec 0 is 1 and this is also 1, so we have 1 by 3 into sec square 0, which is 1 by 3. Now this is nothing but limit of log y equal to 1 by 3. Therefore log of limit of y equal to 1 by 3, we can interchange limit and log. Therefore limit of y as x approaches 0 is e to the power 1 by 3. And finally we have to substitute value of y which we have assumed. So here y is 10x by x to the power 1 by x square, which is e to the power 1 by 3. So in this way, if we have indeterminate powers like this, fx to the power gx as x approaches a, so if we want to evaluate L'Hospital rule for this type of powers, then we will remember that we will start by assuming y equal to fx to the power gx, and then we have to take logarithm on both sides, and then we will convert our limit into either 0 by 0 or infinity by infinity form. So this is all about today's session. I hope you like this lecture. If you are watching this first time, then kindly subscribe this channel for learning each mathematics subject of engineering and share with your friends. Thank you very much.